Foundations of Web Application Security. Web application security protects applications' data and users from attacks. Secure by default. Minimize attack surface. Validate all user inputs. Implement least privilege access. Use encryption for data at rest. Here's a simple explanation with a real-world example. Web application security basics. Imagine you're shopping online, and you enter your credit card number to make a purchase. You want to ensure that your payment info is secure, right? That's where web application security comes in. Secure by default. A good security practice is to assume that all inputs, like your credit card number, are malicious, unless proven otherwise. This helps prevent attacks like SQL injection or cross-site scripting, XSS. Validate user inputs. When you enter your credit card number, the website should verify it's in the correct format before processing the payment. If it's not valid, they shouldn't let you proceed. Least privilege access. Even if a hacker somehow gains access to your account, they should only have access to what's necessary for that specific task. Think of it like using a debit card at an ATM. You can withdraw cash without accessing the entire bank's system. Encryption for data at rest. When you save your payment info on the website, it should be encrypted, like putting it in a safe. This ensures that even if hackers get access to the database, they won't be able to read or use your sensitive data. Common threat landscape. Common threat landscape outlines frequent attacks targeting web applications. Injection attacks exploit unsanitized input. Cross-site scripting undermines user trust. Broken authentication permits unauthorized access. Insecure direct object references expose sensitive data. Here's a simple explanation. Imagine you're at your favorite coffee shop, and they have an online ordering system on their website. However, some people might try to play tricks with the system. Injection attacks are like trying to slip in bad code into the online order form, so it does something nasty to the coffee shop's computer. Cross-site scripting, XSS, is like a hacker using your computer to send bad things to the coffee shop's server, making it think you're saying something you didn't mean to say. Broken authentication is like someone getting into the coffee shop without paying by using someone else's password or credentials. Insecure direct object references, IDOR, are like a thief using your order number to get access to your personal info, like your credit card details. These threats can happen in many places where people use online systems, and it's essential for developers to protect against them. OWASP Top 10 explained. The OWASP Top 10 is a prioritized list of the most critical web application security risks updated periodically to guide developers and security teams. Injection flaws. Untrusted data executed as code. Broken authentication. Session hijacking or credential misuse. Sensitive data exposure. Insecure storage or transmission. Security misconfiguration. Default or weak settings. Here's a simple explanation with a real-world example for each of the OWASP Top 10. 1. Injection flaws. Imagine you're at a restaurant and order food with special instructions, like "I want my steak to be well done." If the chef accidentally puts those words into your steak, it could make you sick. Similarly, if an attacker injects malicious code into a web app through input fields, it can harm the user. Example: a bank website asks for a customer's ID number, but an attacker injects SQL code to access other accounts. 2. Broken authentication. Picture this: you're at a hotel and use your keycard to enter your room. But, if someone gets their hands on that card, they can also get in. In web apps, broken authentication is like a weak lock that lets attackers access sensitive info or take control of user sessions. 3. Sensitive data exposure. Remember the time you lost your phone and some photos were leaked online? That's similar to what happens when sensitive data is exposed due to poor storage or transmission security in web apps. 4. XML external entities, XXE. Imagine an attacker can inject special XML commands that can access, modify, or even delete sensitive data within a web app. That's basically what XXE allows. 5. Broken access control. Think of it like this: a store has separate areas for employees and customers. But if the access controls between those areas are broken, anyone could just walk into the employee-only section. In web apps, that means attackers can access or modify data they shouldn't. 6. Security misconfiguration. Picture a house with open windows and unlocked doors because someone forgot to configure the security system properly. That's similar to what happens in web apps when default settings are used or security is misconfigured. 7. Cross-site scripting, XSS. Remember those annoying pop-ups that appeared on your browser saying "Hello, my friend, even though you never clicked anything? Those were likely due to XSS attacks where an attacker injected code into a web app to steal info or take control. 8. Insecure deserialization. Imagine someone can deserialize, unpack, data in a way that lets them access sensitive info or inject malicious code. That's basically what insecure deserialization allows. 9. Using components with known vulnerabilities. Picture a house with windows made of broken glass. If you use components in your web app with known vulnerabilities, you're essentially using those broken windows they can let attackers right in. 10. Insufficient logging and monitoring. Think of it like this: a store has cameras but no monitors to watch them. In web apps, that means if something bad happens, there's no way to know or catch the issue before it becomes a big problem. Each of these examples illustrates how the OWASP Top 10 list is designed to help developers and security teams prevent common web app vulnerabilities by prioritizing the most critical risks. Injection attacks and prevention. Injection attacks insert malicious code into input fields to exploit backend vulnerabilities. Validate and sanitize all user inputs before use. Use parameterized queries or prepared statements. Implement least privilege for database accounts. Employ web application firewalls to block malicious payloads. Here's a simple explanation and real-world example. What are injection attacks? Imagine you're at your favorite restaurant, and you order a burger with custom toppings. But instead of just listing your toppings, you give them a special command, like delete the menu. If the waiter, or in this case, the website, doesn't check what you typed, they might accidentally do it. How to prevent injection attacks? To keep our menus safe, we can 1. Check what you typed, validate user inputs before using them. 2. Use a special menu, use parameterized queries or prepared statements to keep the commands separate from your input. 3. Limit who can access the menu, implement least privilege for database accounts to prevent anyone from deleting the menu. 4. Block malicious orders, employ web application firewalls to block any suspicious inputs. By following these simple steps, we can protect our menus, or websites, from injection attacks. Authentication and authorization. Authentication verifies identity. Authorization controls resource access. Use multi-factor authentication for stronger identity verification. Implement role-based access control for precise permissions. Employ least privilege principle to minimize risk. Regularly audit access logs to detect anomalies. Here's a simple and clear explanation. Authentication vs authorization. Imagine you're trying to get into your favorite coffee shop. Authentication: you show them your ID card, or a password, to prove who you are. If it matches, they let you in. Authorization: once you're in, they decide what privileges you have inside, e.g., can you order food, use the bathroom, etc. They might say, you're allowed to buy coffee, but not access the back office. In real-life examples, a bank uses authentication when you log into your online account with a password. Then, authorization kicks in when they decide which accounts you can view and what transactions you can make. An airport uses authentication when you show them your boarding pass. Then, authorization controls what areas of the terminal you can access, e.g., whether you can go through security. In short, authentication verifies who you are, while authorization determines what you're allowed to do once you've been authenticated. Session management risks. Session management handles authentication. States vulnerabilities arise when tokens are mishandled. Session hijacking through stolen or predictable tokens. Improper session expiration enables replay attacks. Weak regeneration allows fixation and unauthorized access. Lack of secure cookie flags exposes sessions to sniffing. Here's a simple explanation with a real-world example. Session management risks. Imagine you're at your favorite coffee shop, and you get a receipt with a unique code on it, like ABC123. This code is like a session token that lets you come back to the shop and get your next drink without having to pay again. Risks. 1. Token mishandling. If someone steals or finds your receipt, token, they can use it to get free drinks, just like you. 2. Session hijacking. If someone knows your token and uses it before you, they can get their drink first, even if you were there next. 3. Replay attack. If a hacker gets your token and uses it again after you've already paid, or gotten your drink, they might be able to get another free drink. 4. Weak regeneration. If the coffee shop's system doesn't properly change or regenerate your token, a hacker might be able to use an old one to get something for free. To avoid these risks, it's essential to have secure session management in place. Cross-site scripting prevention. Cross-site scripting XSS is a vulnerability where attackers inject malicious scripts into web pages viewed by others. Prevention relies on input validation, output encoding, and security policies. Validate and sanitize all user inputs. Encode outputs to neutralize scripts. Deploy a robust content security policy. Use frameworks that auto-escape HTML. Here's a simple explanation. Preventing cross-site scripting, XSS. Imagine you're at a restaurant and someone asks the waiter to write a message on your plate, but they sneak in some extra words that can make your plate start dancing or playing music unexpectedly. That's basically what happens with XSS. Attackers put malicious code on websites, making them behave weirdly. To prevent this, 1. Check everything. Make sure all user input, like text you type, is valid and safe. 2. Make the output clean. When a website shows user input back to them, like displaying their message, make sure it can't execute any bad code. 3. Set strong security rules. Define what's allowed and not allowed on your website, like blocking certain types of content. 4. Use tools that help with safety. There are frameworks that can automatically prevent XSS attacks. By following these steps, you can protect users from unexpected and annoying surprises when interacting with websites. Secure file upload practices. Secure file upload ensures only intended safe files reach the server, preventing malicious code execution and data breaches. Validate file type with MIME checks. Enforce strict file size limits. Store uploads outside webroot. Scan for malware before processing. Here's a simple and clear explanation. Secure file upload practices. A simple example. Imagine you're at a doctor's office, and you need to upload your medical records online. You want to make sure that only safe files, like PDFs of your test results, reach the server, not something malicious like a virus or malware. To ensure this, the website might use these practices. 1. MIME checks, like a file filter, it checks if you are trying to upload a legitimate type of file, e.g., PDF, docs. 2. Strict size limits, it won't let you upload huge files that could take up too much space or even crash the server. 3. Safe storage. Your uploaded file is stored outside the website's main folders, making it harder for hackers to access if they get in. 4. Malware scanning. Before processing your file, it checks for any malware or viruses that might be hiding inside. By following these secure practices, you can trust that your sensitive files are safe and won't harm anyone or anything. Data protection in transit. Data protection in transit encrypts data during transmission. Use TLS/SSL to secure HTTP traffic. Implement perfect forward secrecy (PFS). Validate certificates to prevent MITM attacks. Regularly rotate and update cryptographic keys. Here's a simple and clear explanation. Data protection in transit, a secure connection. Imagine you are sending a confidential message through a messaging app, but instead of using an encrypted channel, your conversation is being broadcast on a public street for everyone to see. That's like not having data protection in transit. To keep your messages, or data, secure during transmission, use 1. TLS/SSL, like locking a safe box, TLS, transport layer security, and SSL, secure sockets layer, ensure that all HTTP traffic is encrypted between your device and the server. 2. Perfect forward secrecy, PFS. This is like using a new key for each message. It prevents hackers from decoding past conversations even if they intercept future ones. 3. Certificate validation. Imagine a bouncer at a club, checking IDs to prevent fake access. Validating certificates on both ends ensures you are not being tricked into an MITM, man-in-the-middle, attack. By regularly rotating and updating cryptographic keys, you're like changing the locks on your digital safe, keeping your conversations secure and protected from unwanted eavesdroppers. Encryption at rest strategies. Encryption at rest safeguards stored data against unauthorized access. Use strong rotating key management practices. Implement database-level column and table encryption. Apply full disk encryption on servers and storage. Leverage hardware security modules (HSMs) for key storage. Here's a simple explanation. Protecting stored data, encryption at rest. Imagine you're storing confidential files in a safe deposit box. You don't just lock the box with a weak chain, right? You use a strong, unique combination lock that only you know. Similarly, encryption at rest is like putting a super secure lock on your digital data storage. It keeps your files safe even when they're not being used or transmitted over the internet. Here are some ways to do this. Strong rotating key management. Think of it like changing the combination on your deposit box frequently, so only you can access it. Database level encryption. This is like putting a lock on each file in the safe. It makes sure even if someone gets into the safe, they still need the right key to open the specific file. Full disk encryption. Imagine encrypting the entire safe and everything in it. Even if someone steals the whole thing, they can't access any of your files without the right key. Hardware security modules, HSMs. These are like super secure safes within the safe that store your combination locks. They're designed to be extremely secure and tamper-proof. By using these encryption strategies, you can protect your stored data from unauthorized access, just like how a strong deposit box keeps your physical valuables safe. Input validation techniques. Input validation ensures user-supplied data meets expected format before processing, preventing injection and other attacks. Use whitelisting over blacklisting for safer validation. Apply type length and format checks consistently. Encode output to neutralize malicious content. Enforce validation on both client and server sides. Here's a simple and clear explanation. Input validation, protecting your app from bad data. Imagine you're at a coffee shop, and you order a latte with a weird name like Super Latte. They might not accept it because it looks suspicious. In software development, input validation is like the barista of your app. It checks user-supplied data, like names, emails, or passwords, to make sure it's in the correct format before processing it. This helps prevent attacks like injection, where bad guys try to trick your app into doing something it shouldn't. Here are some simple techniques to keep your app safe. 1. Whitelist. Only accept data that matches a specific format, like latte or coffee. Think of it as only serving drinks on the menu. 2. Type, length, and format checks. Make sure user input is what you expect, e.g., a name can't be too long. 3. Encode output. Protect your app from displaying malicious content, like turning HTML code into plain text. 4. Validate both sides. Check data on both the client side, your user's devices, and server side, your app's backend. By following these steps, you'll help keep your app secure and prevent those pesky injection attacks. Error handling and logging. Secure error handling prevents information leakage while logs provide audit trails. Avoid revealing stack traces to users. Log errors with contextual data securely. Use generic error pages for end users. Implement centralized logging and monitoring. Here's a simple and clear explanation of the importance of secure error handling and logging, along with a real-world example. Secure error handling. Imagine you're shopping online and you accidentally add a wrong credit card to your order. The website crashes, but instead of displaying a detailed stack trace that reveals sensitive information like server paths and database credentials, it shows a generic "oops, something went wrong" page. This is secure error handling in action. By not revealing too much about the site's internal workings, you're protecting yourself from potential security breaches. Logging. Now imagine you're at a hotel and you accidentally spill coffee on your shirt. The front desk staff takes note of what happened and reports it to the management team so they can take steps to prevent similar incidents in the future. That's basically what logging does. It creates an audit trail that helps developers and managers identify problems, diagnose issues, and improve their systems over time. Key takeaways. Secure error handling prevents sensitive information from being leaked. Logging provides a way to track events and make improvements. Use generic error pages for users and keep internal details secure. Implement centralized logging and monitoring to make debugging easier. Let me know if you'd like me to simplify or rephrase anything. Security testing methodologies. Security testing evaluates a web app's resilience to threats and data breaches. Penetration testing simulates real-world attacks on the app. Static code analysis finds vulnerabilities before deployment. Dynamic analysis tests running application for runtime flaws. Automated scanning speeds vulnerability discovery across code bases. Here's a simple and clear explanation of each security testing methodology. 1. Security testing. Imagine you are trying to break into a house, your web app. Security testing checks if there are any locks on the doors/windows that can be picked/opened easily. 2. Penetration testing, or pen testing. Think of it like having someone try to break into your house while you watch from a distance. They're simulating how real hackers would attempt to breach your app's security. 3. Static code analysis. Picture this like checking your house's blueprints before building it. You'd look for any potential design flaws that could make the house, app, vulnerable to attacks. For dynamic analysis, or dyna testing, imagine you are already living in the house, your app is running. This testing checks if there are any issues with how your home app operates, like leaks or electrical problems. 5. Automated scanning. Think of it like having a robot check every room and piece of furniture in your house for potential security risks before you move in. It saves time and finds many issues quickly. Pen testing for web apps. Penetration testing evaluates web apps via controlled attack simulations. Identify authentication and session management weaknesses. Test input validation for injection attacks. Assess error handling and information disclosure. Verify secure configuration and patch management. Here's a simple explanation with a real-world example. Pen testing for web apps. Imagine you are trying to break into a secure bank vault. Don't try this at home. Penetration testing is like hiring a team of expert vault crashers who simulate attacks on your web app. Their goal: find and exploit weaknesses, so you can fix them before bad guys do. Specifically, 1. Authentication. They'll try to guess or steal passwords, like trying to find the vault's combination. 2. Session management. They'll see if they can hijack sessions or access sensitive info, like sneaking in through an unlocked side door. 3. Input validation. They'll test for injection attacks, where they try to inject bad code into your app, like trying to send a fake key through the vault's mail slot. 4. Error handling. They'll see how your app handles errors or sensitive info disclosure, like finding out if the vault's security cameras are on. 5. Secure configuration and patch management. They'll check if your app is properly configured and up to date with the latest patches, like making sure the vault's lock is updated with the latest security features. By running these tests, you can strengthen your web app's defenses and keep it safe from potential threats. Secure DevOps integration. Secure DevOps integration blends development operations and security into a unified CI/CD pipeline, catching vulnerabilities early and maintaining continuous compliance. Continuous security testing embedded in CI/CD pipelines. Automated compliance checks with policy as code. Real-time threat intelligence feeds into build process. Immutable infrastructure reduces configuration drift risks. Here's a simple explanation. Imagine you're building a house, development. You want to make sure it's safe and follows local laws, right? That's where security comes in. Secure DevOps integration is like having a team of builders and safety inspectors working together from the start. They check for potential problems as they build, so you can catch issues early on. In this scenario, continuous security testing, the safety inspectors are always on site, testing the building's structure and foundation as it's being built. Automated compliance checks. The builders have a checklist of local laws and regulations to follow, which is automatically checked throughout the construction process. Real-time threat intelligence. As they build, the team gets updates on potential threats, like changes in local laws or new building codes, and can adjust the plan accordingly. Immutable infrastructure. They use pre-made, ready-to-assemble parts to reduce the risk of errors or changes that might compromise the building's integrity. By integrating development and security from the start, you can build a solid, safe, and compliant house, or software system, that meets all the necessary requirements. Role-based access control. Role-based access control (RBAC) limits system access by assigning users to predefined roles, each with specific permissions. Assign roles based on job responsibilities. Enforce least privilege access. Simplify permission management. Enable audit and compliance. Here's a simple explanation. Role-based access control, RBAC, in a nutshell. Imagine you're at a hotel with different rooms for guests, staff, and owners. Guests can only access their room and common areas like the lobby. Staff have access to all rooms, but not the owner's suite or sensitive areas. Owners have full access, including the staff's areas and confidential spaces. RBAC works similarly. It assigns users, like guests, to specific roles, like guest, staff, owner, that determine their permissions, what they can access. This way, you limit who has access to what, make it easier to manage permissions, and help with audits and compliance. Vulnerability management workflow. Vulnerability management workflow is a systematic process for identifying, evaluating, and mitigating security weaknesses in web applications, ensuring continuous protection by prioritizing threats and tracking remediation status. Scan web apps for known vulnerabilities. Assess risk based on impact and likelihood. Prioritize fixes using risk scoring. Track remediation until closure. Here's a simple explanation. Vulnerability Management Workflow. Imagine you're at a coffee shop, and they just installed new security cameras to protect customers and employees from potential threats. A vulnerability management workflow is similar. 1. Scan for threats. The coffee shop's IT team regularly scans their premises, like a web app, for any known vulnerabilities, like open doors or windows. 2. Assess risk. They assess the risk of each identified threat by considering how likely it is to happen and what impact it would have on customers, employees, and the business. 3. Prioritize fixes. Based on the risk assessment, they prioritize which security weaknesses to fix first, like closing open windows or installing new locks. 4. Track remediation. They track the progress of fixing each identified threat until it's fully resolved, like monitoring the installation of new cameras. By following this workflow, the coffee shop ensures continuous protection for their customers and employees by prioritizing threats and tracking remediation status. Third-party component security. Third-party component security ensures that external libraries, frameworks, and plugins integrated into web applications are safe, up-to-date, and free from known vulnerabilities. Regularly update and patch all external dependencies. Use automated vulnerability scanners for component checks. Implement strict license compliance and provenance verification. Enforce runtime controls to limit component impact. Here's a simple and clear explanation. Keeping external code safe. Imagine you're building a house, but instead of using regular bricks, you also use specialized blocks made by others, like a fancy door lock. These external bricks can be prone to weaknesses or holes that hackers might exploit. To keep your entire house, application, secure, you must ensure these external bricks are regularly updated with the latest fixes, patches. Scanned for potential vulnerabilities using automated tools. Used in compliance with their licenses and origins verified. Limited in how they can affect the overall system. By following these steps, you can help prevent security issues that might arise from using external components. Mobile web application security. Mobile web applications deliver content to mobile devices via browsers, requiring specialized security controls to protect data, ensure integrity, and maintain secure connections. Use HTTPS to encrypt data in transit. Validate and sanitize all user inputs. Implement secure authentication and token storage. Regularly update mobile libraries and frameworks. Here's a simple explanation. Mobile web app security 101. Imagine you're accessing your online bank account on your phone. To keep your sensitive info, like account numbers and passwords, safe, mobile web apps use special security measures. 1. HTTPS. When you tap into the app, your data is encrypted like a secret message. This keeps bad guys from intercepting it. 2. Input protection. If you enter your details, like login credentials, the app makes sure they're clean and can't be used for evil purposes. 3. Secure login and tokens. The app uses strong authentication methods to verify who you are, and stores tokens securely so only authorized users access your data. 4. Regular updates. Like updating your phone's OS, mobile web apps also get updated regularly to patch vulnerabilities and fix security issues. These measures help protect your sensitive info and maintain a secure connection when using mobile web apps. Cloud hosting security considerations. Cloud hosting leverages shared infrastructure to deploy web applications. Security requires managing shared responsibility, data isolation, and provider controls. Assess providers' security certifications and compliance frameworks. Implement strong identity and access management controls. Encrypt data at rest and in transit. Regularly audit logs and monitor for anomalous activity. Here's a simple explanation with a real-world example. Cloud hosting security considerations. When using cloud hosting, it's essential to consider security because you are sharing infrastructure with others. Think of it like a shared office space. Imagine you work in a co-working space where multiple companies are located under the same roof. You want to ensure that your company's sensitive data is safe from other businesses and the building's management. To secure your office, cloud hosting, follow these basic steps. 1. Assess the provider's security. Check if they have strong certifications, like ISO 27001 or SOC 2, which guarantee their security standards. 2. Manage access carefully. Control who can access your data and applications using strong identity and access management controls. 3. Keep data secure. Encrypt your data both when it's stored, at rest, and when it's being transferred, in transit. 4. Monitor activity regularly. Regularly review logs and look out for suspicious activity to prevent unauthorized access. By following these steps, you can ensure that your cloud-hosted applications and data are secure and protected from potential threats. Regulatory compliance requirements. Regulatory compliance ensures web applications meet legal and industry standards for data protection. Adhere to GDPR for EU user data privacy. Implement PCI DSS to secure payment card information. Follow HIPAA for safeguarding health data. Conduct regular audits and penetration tests. Here's a simple explanation. Regulatory compliance. Imagine you're running a coffee shop in Europe, EU. You need to follow EU laws to protect customers' personal data, like their names and addresses. Similarly, when building web applications, regulatory compliance means following rules set by governments and industries to keep users' information safe. This includes protecting user data in the EU with GDPR, like a secure filing cabinet. Safeguarding credit card info with PCI DSS, like using a lock safe for payment details. Keeping health data private with HIPAA, like having a doctor's office securely store medical records. To stay compliant, developers conduct regular checks on web applications to ensure they're secure and follow the rules. It's like hiring a security expert to inspect your coffee shop for any vulnerabilities. Incident response planning. Incident response planning outlines steps to detect, contain, eradicate, and recover from web application security incidents. Establish clear incident detection indicators. Define roles and responsibilities. Create containment and eradication procedures. Plan communication and post-incident analysis. Here's a simple and clear explanation of incident response planning. Incident response planning: what to do when bad things happen. Imagine your favorite restaurant has just been hit by a cyber attack, causing customer data to be stolen. The staff needs to know what to do next. Step 1. Detect. Establish red flags that indicate something might have gone wrong. For example, unusual login attempts from unknown locations. Strange network traffic or server errors. Customer complaints about suspicious emails. Step 2. Contain. Stop the problem from getting worse. This means locking out hackers who are trying to get in. Removing malicious code from your systems. Taking down affected web applications to prevent further damage. Step 3. Eradicate. Get rid of the bad guys and fix the issue. This includes identifying the root cause of the problem, fixing security vulnerabilities that allowed the attack, updating software and systems to prevent future attacks. Step 4. Recover. Get your business back on track. This means restoring data from backups, notifying customers who were affected by the incident, reviewing what happened to improve your security processes. By following these steps, you can create an incident response plan that helps you stay one step ahead of cyber threats and protect your business's reputation. Business continuity and recovery. Business continuity and recovery keep web applications available and protect data after disruptions. Identify critical application components. Implement redundant hosting and failover. Automate backup and restore testing. Establish clear incident response playbooks. Here's a simple explanation. Keep your business apps running after disruptions. Imagine your company's website is down due to a server crash, and you can't process customer orders. To prevent this, you need a plan for business continuity and recovery. What you need: 1. Identify critical parts. Determine which parts of your application are essential and must keep working even when something goes wrong. 2. Redundant hosting. Have multiple servers or hosting locations to ensure that if one crashes, the others can take over immediately. 3. Automate backup testing. Use software to regularly test whether data can be restored in case of a failure. 4. Clear incident response plan. Create step-by-step guides for what happens when something goes wrong, so everyone knows their role. This helps keep your website and apps running even when there's an issue, protecting customer data and business operations. Security awareness training. Security awareness training educates users on safe practices and threat recognition to protect web applications. Recognize phishing emails and suspicious links. Use strong unique passwords and enable MFA. Report security incidents promptly to the IT team. Regularly update software and apply security patches. Here's a simple explanation with a real-world example. Security awareness training. Just like how you are taught to be safe online, your coworkers need to learn too. Example: imagine John is browsing his work email on his phone during lunch. He gets an email that looks super official, but something seems off. it asks him to click a suspicious link. If John knows from security awareness training how to spot phishing emails, like this one, uses strong and unique passwords, has enabled multi-factor authentication, MFA, for extra protection, knows to report weird incidents to the IT team ASAP, John would be way more secure online. And so can your coworkers with proper security awareness training. Monitoring and detection tools. Monitoring and detection tools continuously analyze web traffic logs and system metrics to enable rapid identification of anomalies and potential attacks. Real-time traffic analysis for instant threat identification. Log aggregation to correlate events across services. Automated alerts for suspicious behaviors. Dashboards visualize attack trends and metrics. Here's a simple explanation with a real-world example. Monitoring and detection tools. These tools watch over your website's traffic logs and system stats to quickly spot unusual activity that might be a security threat. Example. Imagine you run a popular e-commerce site. Your monitoring tool notices a sudden spike in login attempts from an unknown IP address. It immediately alerts you, so you can take action before the potential threat turns into a problem for your customers and business. Future trends in web security. Future trends in web security are emerging technologies and strategies that will shape the next generation of protecting web applications from evolving threats. Zero Trust architecture gains mainstream adoption. AI-driven threat detection becomes standard. Edge computing security models rise. Quantum-resistant cryptography is integrated. Here's a simple explanation with a real-world example. Future trends in web security. 1. Zero Trust architecture. Imagine you're at an airport, and every employee has access to all areas, including sensitive parts of the facility. Zero Trust is like having a digital version of that, where every user or device, not just employees, is verified and authenticated before accessing any part of your web application. 2. AI-driven threat detection. Picture a smart alarm system for your home. Just as it learns to recognize unusual patterns, AI-driven threat detection can learn to identify unknown threats in real time, improving the security of your web application. 3. Edge computing security models. Think of a local coffee shop where the internet is provided by a small router that only allows necessary connections. Edge computing does something similar for large networks. It reduces data traffic and improves security by processing data closer to where it's generated or used. 4. Quantum-resistant cryptography. Imagine sending highly confidential documents through an encrypted email service. Quantum-resistant cryptography ensures your web application can protect sensitive information even if someone were to get access to future quantum computers, which are expected to be much more powerful than today's computers. Building a secure culture. A secure culture ensures every team member practices security proactively. Continuous training builds awareness and skill for secure coding. Leadership models security rewarding proactive risk mitigation. Clear policies provide guidelines and enforce consistent practices. Regular audits surface gaps and guide improvement. Here's a simple and clear explanation. Building a secure culture. Imagine a construction site where every worker has a personal safety plan, receives regular training on safety procedures, and is rewarded for spotting potential hazards. This mindset ensures everyone stays safe on the job. In software development, building a secure culture means every team member takes security into account in their daily work. Continuous training helps them stay up to date with best practices. Leadership promotes security as a key priority, rewarding teams that find and fix security issues early. Clear policies guide everyone's behavior and ensure consistent security practices. Regular audits identify areas for improvement and help the team get better over time. This way, you can build a secure culture where every developer is proactive about security, just like every worker on that construction site. Best Practices Checklist. A structured list of actions and checks that ensure web applications meet security standards. It covers authentication, input validation, secure configuration, and ongoing monitoring. Use strong multi-factor authentication. Validate and sanitize all user inputs. Encrypt data at rest and in transit. Regularly update libraries and dependencies. Here's a simple explanation with a real-world example. Best Practices Checklist. Imagine you are ordering food online from a restaurant website. You want to make sure your personal and payment info is secure, right? Use strong multi-factor authentication, like when you order, the site asks for both your password and a one-time code sent to your phone. Validate and sanitize all user inputs. If you put in a special character like an asterisk, backslash, or bracket, it gets filtered out by the website. This helps prevent hackers from putting malicious code into forms. Encrypt data at rest and in transit. When you input your credit card info, it's protected with encryption, making sure only the restaurant sees the numbers. When the site sends this to their payment processor, it's also encrypted so nobody else can read it. Regularly update libraries and dependencies. It's like keeping your phone's apps up to date. The website needs to ensure its core software is secure by patching vulnerabilities. By following these best practices, a restaurant website can protect customer info and maintain trust online. Summary and takeaways. Web application security protects online systems from attacks such as SQL injection, XSS, and other code-related threats, encompassing secure coding, threat modeling, and continuous monitoring. Secure coding practices reduce common vulnerabilities. Regular vulnerability scanning identifies weaknesses early. Employ WAFs to block malicious traffic. Continuous monitoring ensures rapid incident response. Here's a simple and clear explanation for the slide content. Web application security, protecting online systems. Imagine you're shopping online, and your favorite website is hacked because of a tiny mistake in their coding. That's what web application security is all about, keeping online systems safe from threats like SQL injection, where hackers inject bad code into databases, cross-site scripting, XSS, and other common attacks. 3 key strategies. 1. Secure coding. Write good, safe code to prevent basic mistakes. 2. Vulnerability scanning. Regularly test for weaknesses before they become big problems. 3. Continuous monitoring. Keep a close eye on your system 24/7 to catch and fix issues quickly. By following these simple strategies, you can protect yourself and others from online threats.